Hello scientific people. So here is the DA paper that we recently gave, and this is set 1 of the DA examination of physics based on chapter light, right? So let's solve all the questions over here. Here we are given that this is a glass object and the light is incidenting on it, and finally the light is definitely going out. So this cannot be mirror, because if this is a mirror, then light would reflect back in the same direction. That means it has to be either a concave lens or convex lens or a glass slab. Now what happens is, this is basically a concave lens. In concave lens, when the parallel rays meet, they go out. This is a diverging action, and this lens is a diverging lens, right? Now instead, if we have a convex lens, it is something like this. Parallel rays, they actually meet. So this is a converging action, and over here we can see that the parallel rays, they are going away, so it is a diverging action, and this lens is concave lens, so this is third option. Now here the figure below shows a ray of light passing from glass into air, and we know that whenever a ray, this is glass, this is air, when a ray of light falls like this is the point of incidence. From here, if I draw the normal, I see that the angle of incidence is 0 degree. And if the angle of incidence is 0 degree, angle of refraction again is 0 degree. So in order to keep up that, it has to go straight without deviation. Q is the correct answer. That means this is the correct answer. A diver is standing at the edge of the spring board and viewing a pool. So when you see anything which is inside a denser medium, the bottom part always appears to be raised, right? So, and it is due to the fact, let us understand that over here. So suppose this is the medium surface, and here it is air, here suppose it is water, and if there is a fish which is over here, suppose this is first incident ray, this is second incident ray. Since this is falling at an angle 0, it has to go straight like this, but this one will be bending away from the normal. So both the refracted rays are not going to meet. So if we extend them in the backward direction like this and like this, we see the image of the fish over here. This is the image, this is the object. So the objects, they appear raised to us. In the same way, consider fish to be the bottom of the swimming pool, which will appear raised to us. So the correct answer is higher. Okay. Due to the refraction, the bottom of the pool would appear deeper than actually it is. No, right? It is going to be appearing quite raised, higher than actually it is. More colorful, this is correct, this is wrong answer. Exactly where, wrong answer. Deeper than actually it is also wrong. Higher than actually it is. This is the actual position, and higher. So we find the swimming pool somewhere over here bottom, so it appears to be higher. Correct answer is 2. Now what happens when a light ray enters the glass from the glass slab from the air? So it is coming from rarer medium to denser medium, so it will bend towards normal. This is bending away from normal, this is bent towards normal. Correct answer. Now question number 5. I is angle of incidence, R is angle of refraction. Then for given color means we are talking about a fixed wavelength, fixed frequency of light, right? And so here this is the medium 1, this is medium 2. Suppose this is rarer medium and this is denser medium. So ray of light strikes like this, point of incidence, normal, angle of incidence, instead of going straight, bend towards normal. This is angle R. Now refractive index is always of second medium with respect to medium 1. Now that is equal to refractive index of medium 2 with respect to medium 1 is equal to sin I upon sin R. And if the speed of light over here is c, speed of light over here is v, this is also equal to c by v. So index of medium 2 with respect to medium 1 is sin r upon sin I. This is wrong. Of 2 with respect to 1 is equal to sin I upon sin r. Correct answer. When a light enters a medium of lower refractive index, its velocity increases. When a light enters inside a denser medium, speed decreases, and when it enters inside a rarer medium, speed increases. But the speed will always remain less than 3 into 10 raised to 8. Maximum it can be 3 into 10 raised to 8 because light ray cannot travel more faster than the light itself. That is 3 into 10 raised to 8 meter per second. Shown here is how a ray of light passes from one medium to the another. So this is medium A, and instead of going straight, we can see that this is moving towards normal. So definitely this has to be denser, and this is rarer medium. And the speed of light when it travels from A to B, so it is going from rarer to denser, so the speed will decrease, right? A hunter sees a fish which is swimming in a clear water as shown in the figure. To hit the fish, he should take the aim adjusting for fish motion and exactly at the depth? No, because if the fish representation of where the hunter sees the fish, so actually the fish is somewhere over here. So little below is the correct answer, because really the fish is here, not here. So if we actually throw the spear over here, we are going to miss it, because here this is only the image, right? Okay. This was a question from our video discussion only, and we know that the day becomes longer by 2 minutes, and the day becomes the sunrise and the sunset actually becomes 2 minutes early and late. So the entire day seems to be 4 minutes longer, right? So the answer is longer than it actually is. Here, this is violet light, that means a monochromatic light. So instead of going straight, it is going to bend towards normal. Now again from here normal, it is going to bend away from the normal. Again from here it is going to hit like this, and from here it is again going to come out like this. So what's going to happen is the first prism is going to bend the light ray, and the second prism is again going to bend the light ray by a larger amount, right? So ray of violet light is made to pass through both the prisms showing above. As shown above, we are likely to observe that violet ray emerges from the second prism, is parallel to the base of the second prism. No, it is not parallel. Deviates towards the base of the second prism is the correct answer. Is perpendicular to the base of the prism, incorrect. Parallel to the violet light, incorrect. I mean parallel to, this ray cannot go like this, then and only then it can become parallel. So all other options are wrong. When light is dispersed, color among the following deviates the most. We know that the speed Vibgyor, let's write down. The speed of the violet light is the least, so the bending of violet light is the maximum. But here we don't have violet light, we don't have indigo 2, but we have blue. So blue has the least speed out of all, so it is going to deviate the maximum when we pass it through the prism. The object in question number 12, this is the head. This light is coming from the head of the object, and finally this is the same light which is coming out from the head. So the head would be appearing over here and the tail would be appearing over here, so the image would be inverted. Let's go through all the diagrams. Now we can see that this is an incorrect option. It is because instead of going straight, it is bending away from the normal. This is air, this is glass, and the ray is going from rarer to denser, even it is bending away from the normal. So wrong diagram. Here the ray of light is actually going from rarer to denser, so it is bending towards. So this is correct. right? But till here it is correct. Now from here, instead of going straight, actually the normal is like this. This is the normal. So instead of going straight, it has to go away from the normal, because this is going from denser to rarer, but over here it is going towards normal, which is wrong. It should go in straight line, but instead of going straight, it must bend away from the normal. Here it is bending towards normal. So wrong diagram. This is correct. Instead of going straight towards normal, instead of going straight away from normal. Here what is the mistake? Instead of going straight, it is moving away from normal. It should bend towards normal. Rarer to denser. Wrong diagram. Image formed by convex mirror. We always know that the image formed by convex mirror is always first ray, second ray. Now this is focus, so goes in such a way that it passes through focus and it goes like this. So if I extend, both refracted rays do not meet, so final image is formed over here, and since the refracted ray is not meeting, the image is virtual, smaller than the object and on the other side of the mirror, right? Erect, virtual and smaller. Correct answer. Which of the following is true for a real image? Rays never meet. Wrong. Rays meet. Correct. Formed by plane mirrors. Incorrect. Always erect. Incorrect. Real images are always inverted. B option or the second option is the correct answer. Babita was doing an experiment using the mirrors and observed two images. P was inverted and Q was erect. Based on this, we can say that image P is virtual image and image Q is a real image. Image P is real and image Q is virtual. Both are real, both are virtual. See, when we do an experiment with the mirror, suppose whatever the mirror that is, we don't care. Suppose we take it as a concave mirror and we keep the object like this. Now this is the object, so in accordance to that I am getting one inverted image and I am getting one, this is image number 1, image number 2, this is erect image. So that means the inverted image has to be real, this has to be virtual. So the correct answer is P was inverted, so P has to be real. So the correct answer is 2. We know that the dentists, they use concave mirror, and in concave mirror what we apply is the object is kept between P and F. So the teeth is the object which is in between F and P, and we know that these two rays are not going to meet, so we extend them in the backward direction. So the dentist can see highly enlarged, erect and virtual image of the teeth. So the correct answer is concave mirror. Okay. Here a lightened candle is placed between concave mirror and the screen. Image is obtained on the screen. Because it's a real image, real images can be obtained on the screen. The concave mirror is now replaced by convex mirror, and we know that convex mirror always produces virtual image which will never be obtained on the screen. So the answer is no image will be obtained on the screen, right? Because whatever image we see will be over here and nothing will be appearing on the screen. Which among these is the most used as side view mirror in the vehicles? The answer is convex mirror. It is because the convex mirror has larger field of view. That means this is the object. I am considering two rays which are hitting the edges of the convex mirror. So they are going to go like this whole area is called the field of view. Instead, if we use a small plane mirror, then the field of view hitting the edges and going like this, you can see that this area is smaller than this area. Field of view of convex mirror is very large, and the concave mirror would be having still lesser field of view than the plane mirror. So the correct answer is convex mirror. In the diagram shown above, C is the center of curvature, F focus, P pole, radius of curvature, focal length. Focal length is always half of the radius of curvature. Second option. Now, according to the laws of reflection, incident angle is always equal to reflected angle. Both incident angle and reflected angle are measured from the normal. Does this law hold true for the concave mirrors? Answer is yes. If reflection is taking place, laws of reflection are always obeyed. This is the point of incidence and the normal always passes through C. This is angle of incidence. This is angle of refraction. Both are always equal. In the diagram shown below, the light ray is incident on a convex mirror. So when a light is falling on a convex mirror, it is parallel. This is the point of incidence, and we know that this is the normal which passes through C, and it is going to go like this, and if you extend, it passes through focus. So the ray afterwards, it is going to pass through X. It is a diverging mirror. See the concave mirror and answer the following questions. If in this mirror the image is real, smaller than the object, then where is the object likely to be? The answer is beyond C. So when we keep the object beyond C, image is formed between F and C, smaller than the object, right? So beyond C is the correct answer, and let us check all other answers here. When you keep the object at C, image is also at C but same size. Incorrect. Between F and mirror you will have virtual image. Here we are being asked real image. Incorrect. Focus and center of curvature, the image would be larger. Here the image should be smaller. So we have 2. Consider light ray P. Which path KLMN will be it reflected? Ray number P. This is ray number P, and we know that this is the point of incidence and the normal passes through C, so this is the angle of incidence. So at the same angle it should pass, so the correct answer is the focus. N is the correct answer. With a converging mirror, that means a concave mirror, image of the object is shown below. Where should the object have been placed in order to obtain this image? Okay, so the image of the object is shown in the figure below, and where is the image? This is F, this is C, and this is the image. Okay, so we know that when the object is placed between F and pole, we get the highly enlarged, magnified, virtual and direct image behind the mirror. So the correct answer is S, right? So hopefully guys you have understood the problems over here and the solutions as well. Be very specific, we read the question very properly, because without understanding the questions you will never be able to attempt the answers. The most important thing is that pay attention to the basic concepts, understand them well, like where is normal passing through from the concept of mirrors, right? So hopefully you have enjoyed the explanation. If you have any doubts, do comment in the comment sections.